Yeah, you found it quickly, Kate. Turn right to it. She doesn't like that I gave it. I'm sorry. I won't say anything to you again. So this is the page that I want you to look at. This page has most of the topics and identities that we've talked about. So the first thing talks about the periodic property, which we went over, which seems like a while ago. The Friday, like 2 Fridays ago, pretty much. And that just says that if you add 2 pi or subtract 2 pi to any angle, those are coterminal angles. The sine of a coterminal angle is the same as the sine of an angle. So if I have the sine of 5 pi, it's the same as the sine of 9 pi, which is the same as the sine of 13 pi. So those are what the periodic properties say. The signs of trig functions, that just tells you where an angle is located. We're going to go over that again today. But we've been looking at like x being positive, y being negative, and the quadrant they're located in. The next 11 are the fundamental identities that we talked about on Wednesday. And then the bottom 6 are the cofunction identities, which we talked about on Tuesday and last Tuesday as well. So I just went over a whole bunch of things that we've talked about. The other thing that we haven't really mentioned a lot of in the trig sense would be the even and odd properties. But back in algebra, when we talked about algebra, in pre-calculus, we said a function is even if it has y-axis symmetry. It's odd if it has original symmetry. That's what we talked about when we did graphs of even and odd functions. When it kind of goes with trig functions, the angle is negative, so I usually call this a negative angle property or a negative angle identity, but we refer to it also as even and odd. So if you look at the second one there, it says the cosine of a negative angle is equal to the cosine of a positive angle. Oh, come on. And I want to show you like how that property works, how the identity works, not just because it's there. And no, we're not going to do like a big long proof, but just to show you a picture. Is it green? Yeah, okay. So for 22, and of course it's not calibrated. Yeah. 22 gives you the cosine of an angle, and they say it's equal to 1/3. And you're asked to use the trig identities. So the second one goes along with that even-odd identity, but again, I'm going to kind of show you how that even-odd identity works. And I'm going to show you with a triangle so that you have a picture to kind of think about how to find the solution. There we go. Okay, so the cosine of the angle is equal to 1/3. Part B says we're going to find the cosine of the negative angle. The identity says that's really just equal to the cosine of whatever your positive angle is. And cosine is an even function. Even functions, if you plug a negative number in, you get the positive answer out, or the original answer out, we say that it is an even function. It also has y-axis symmetry. So that means that by this identity, if you know the cosine of the angle, the cosine of the negative angle is the same exact thing, which is 1/3. Okay, so I want you to think about this as a picture now. If we draw a triangle, I'm going to place that triangle in the first quadrant because cosine is positive. Cosine is positive in the first quadrant. X and y are positive in the first quadrant. What 2 sides of the triangle, Michael, would we use if cosine is 1/3? How would we label the triangle?
The bottom, the base would be 1, and then the hypotenuse would be 3.
Right, so a base or the adjacent is 1, the hypotenuse is 3. All right, so a positive angle is this angle right here. That's a positive angle. Brandon, where is negative angle located? How do you find a negative angle?
You just go down beta the other way.
Right, so angles can be positive because you move counterclockwise. They're negative because you move clockwise. They're all mixed up. So if I go down in the other way, instead of going up, I have that same angle, but now it's negative instead of being positive. But Brandon, it has the same exact value of 1, and the hypotenuse is also still 3 because it's the same triangle. It's just now we're moving down for the negative direction instead of up for the positive direction. The only difference is that whatever this height would be, which is going to be the square root of 8, so this would be 2 square roots of 2. This guy down here would just be negative 2 square roots of 2. But if you're finding the cosine of the negative angle, it's still the adjacent, which is 1, and the hypotenuse, which is 3. So any cosine of a positive angle has the same exact value for the cosine of a negative angle. And that's because x is positive. You're not changing the x value because you're still on the positive x-axis. So that's why the cosine of 1/3, or is equal to 1/3, the cosine of that negative angle is still equal to 1/3 because you're not changing the x distance. It's not becoming negative. You're still moving that same x distance, except now we're just going down to get to the bottom of the triangle instead of going up to get to the top of the triangle. Questions? Why isn't the 3 negative? Because the 3 is really the radius of your circle, because technically there's a circle that goes around every single triangle that we draw. And a radius can never be negative. Technically this side, the length of it isn't negative, the direction is just telling us we're moving down. But that's still the radius, and the radius is always a positive value. Because it isn't really moving down or over, it's a diagonal value. Good question. Another reason, if you square this number to use Pythagorean theorem, anytime you square a negative, it's always going to be a positive value as well. How about another question from the worksheet? Yeah. Yes. So 18A and B want you to use trig identities to simplify the following. We said on Wednesday that we were transforming one side to be the other. So essentially, we want to transform the left side to be equal to 1. So we're going to see if we can do some algebra to try and break it down to equal 1. Brandon, when you have parentheses, what do you generally do to get rid of parentheses? You foil it. So we're going to do the algebra part, get rid of the parentheses. Cosecant times cosecant. Now it's squared, just like x times x is x squared. So this is cosecant times cosecant squared. The little 2, the square part, goes next to the cosecant, not the angle. We're not squaring the angle, we're squaring the x. We're squaring the cosecant. And then we have cosecant times cotangent. Cotangent times cosecant, but that's negative. I'm just writing them in the order that I wrote the first one. And then finally, negative cotangent times positive cotangent would be negative cotangent squared. Or it would be negative x squared, negative y squared, if you want to replace them thinking about variables. So Chelsea, what do you notice happens with this big expression?
Oh, the middle.
Yeah, the middle cancels. And we end up with cosecant squared minus cotangent squared. So if you still have that list of identities out, is there an identity that talks about either cosecant or cotangent? Michael?
You can make the cosecant 1 plus the cotangent squared.
Yeah, so 1 plus cotangent squared equals cosecant squared. That's one of the 3 Pythagorean identities. Substitution algebraically says you can take something out and replace it with whatever it's equivalent to. Well, we're taking out the cosecant squared, we're replacing it with whatever it's equal to. In this case, it's equal to 1 plus cotangent squared. And then it's like magic. This is math magic in my mind. Like, woo, these cancel, and now magically 1 equals 1. I love these problems, but I love puzzles. This is like logic puzzles. I have a whole bunch of puzzles of like 1,000 pieces that we've like epoxied together. They make really pretty pictures. My brother and I used to love to do puzzles together. It's probably the only thing my brother and I have in common. Nothing else. I'm the hard worker, he's the slack.
We did one for Thanksgiving. We got 1,000-piece puzzle.
Did you do one over Thanksgiving? What was it?
It was part of New York.
Oh, cool. Yeah, we like this. Any other questions? How did everybody do on this one? We'll spend like a good deal. This is just a little glimpse into them. We'll do these a lot. And it like the problems get a little more involved. It's really rewarding to break it down. At least for me. It's pretty cool to break it down into something.
I was trying to figure out what it was called because I was looking through my notes. But like when we did the imaginary numbers and like when we foiled it, can we still use that same rule with the puzzle?
Yes. So those are conjugates.
Yeah, I was
Yeah.
kind of love that.
Yeah.
To get started.
So because they're conjugates, one is a plus and one is a minus, the middle terms cancel. It's exactly the same rule with imaginary numbers. It's exactly the same rule with x plus 7 and x minus 7. They always cancel out. Yes, you can use that, most definitely. That same rule applies to algebra and trig. Conjugates. So complex conjugates canceled, you got it, or the imaginary number disappeared. In this case, it's that middle terms that are canceling. Any other questions? So I would like to collect that just to kind of take a peek to see how you did. I'm not going to grade this one for accuracy, but I still want to get a gauge as to like what we need to go over next week before next Friday's test. So this gives me a good gauge as to kind of take a mental note. So the extra reviews that I can go over with you and extra problems that we can look at based off some of the facts that we might still need to kind of review. So today, we are still doing triangles, still with right triangles. Trig is triangles, the study of triangles. In your packet, it's the last section of this packet. So this packet goes from 4.1 to 4.4. And then we'll get another packet that starts like doing more application stuff. So the first half of this packet is really kind of building a foundation and getting to understand trig and how you work with a triangle, how you work with a unit circle. So the next packet is still chapter 4, but it kind of goes more on the application side. So if you look for section 4.4, it's page 8A. We're going to spend 3 separate days on this section, kind of just taking it piece by piece. So today we're going to just look at kind of defining trig functions 1/3 time. So we've defined all 6 of them now. This will be 3 times. We've given a definition for each one in sections 4.2, 4.3, and now 4.4. Monday we'll talk about something called a reference angle. And then Tuesday we'll work on finding angles from the unit circle that we don't have memorized. So maybe like a pi over 12 angle. We know pi over 3, but how can we find pi over 12? So that'll be kind of next week to finish up this first part of the chapter. So definitions of trig functions of any angle. So we've defined trig functions before using the same definition. So I'm going to draw myself a lopsided circle. Too lopsided for me. A little better. So this definition is pretty much the same definition that we went over in section 4.2. Similar to the last section 4.3 that we did on Monday and Tuesday, and now we're looking at it one more time. So we have an angle in standard position, meaning it's on the positive x-axis. The point xy is on the edge of our circle. It creates an angle because it kind of finishes the angle. That's on the terminal side of the angle. So right here is our angle in standard position. XY is a point on the edge of the triangle, or the edge of the circle. And that point helps us then create a triangle. So even though we have a circle and the edge of a circle, that point is also giving us a location and a distance of the size of the triangle. So the distance we went to get to that point, we traveled a little bit to the right to get to x, we went up a distance to get to y, and then because it's still really a circle, the radius of the circle is the distance from the center to the edge. So this is saying that to find the radius, we would really take the square root of x squared plus y squared. Because why? Why is r equal to the square root of x squared plus y squared?
Because Pythagorean theorem says, a squared plus b squared equals c squared. And once you add a squared plus b squared, you have to take the square root of them.
Right, and our a squared and b squared are x and y. Our c squared is r squared. So if we want to get r by itself, we have to take the square root of them. That's how that little formula is really created. So the radius is equal to x squared plus y squared because of the Pythagorean theorem. So the Pythagorean theorem, circles and triangles really are like the ballpark of trig. That's the foundation of trig. So over here, we're now going to define sine. If it's a unit circle and it has a radius of 1, we said that the sign was y. So on the unit circle, in your ordered pair, the sign is the y value because sine is opposite. However, we're no longer on just the unit circle, we're on any circle. So now it's going to be y over r because the radius doesn't have to be 1. I mean, it is 1 on the unit circle and we have those values memorized, but now we're saying this is any angle. So the radius could be 1 and then it would be y over 1, or the radius could be 5 and then we would have a 5 there. Whereas if we wanted to find the cosine on the unit circle is but now because we have any circle, it's going to be x over r, yeah, because it's the adjacent over the hypotenuse. And then Chelsea, the tangent would be equal to y over x. So then to get the other 3, they're reciprocal, so you just flip what we have around. So the cosecant is r over y, the reciprocal of the sine. The secant is r over x, reciprocal of cosine, and cotangent is x over y, reciprocal of tangent. So this is like the general form. So if you think back to the quadratics, you can factor a quadratic, you can complete the square, you can use square roots, you can use the quadratic formula. The quadratic formula is the formula that you can use for any factoring or any quadratic equation. These 6 definitions are the definitions for trig functions that you can use for any circle. So it's the big general form, not the specific one that only works with a unit circle. So we are going to look at the first problem, which is kind of worded like this, but it actually gives us a point. So it says find the exact value of just sine, cosine, and tangent of an angle that has a point -4,3 on the terminal side of this angle. So I think we're working with circles, but also working with an xy axis. So here's xy. Libby, how would you draw the point, or plot the point -4,3? You don't really draw the point, you want to plot it.
Go left 4 and up 3.
Right, left 4, up 3. So if we were just plotting a point, you would move left 4, up 3. So now that point, it says, is on the terminal side of an angle. So whenever we make an angle, it starts in the center. And generally, it starts on the x-axis. So this would be our angle. However, if I make a triangle with that and try and connect the end to the beginning, that isn't a right triangle, that's an obtuse triangle. We can't work with obtuse triangles yet. So instead, we're going to connect that to the negative x-axis so that we still create our triangle. So we're going to be looking at the little angle inside instead of the outside angle. So really, there is, let's see if I can draw a circle that goes around here. Yeah, kind of. There we go. So technically, there's this circle that's going around. On the edge of the circle is this point. Inside the circle, we now have a radius and a triangle that we found by using the point -4,3. So if we label this triangle, the distance to get to that point is 4, but because we're on the negative x-axis, it's -4. So it's still a positive distance, but we're now on the negative side of the circle. So it's a negative 4 there. The distance we went up to get to the top of the point would be 3. What's the radius of this circle? So r is equal to x squared plus y squared. Taking the square root of that, Brendan?
It's 5, and isn't this one of the, isn't this the 3, 4, 5 triangle?
Exactly. So it is the 3, 4, 5 triangle. So if you didn't recognize it, you would end up getting the square root of 25. Or it's a 3, 4, 5 triangle. So we have a picture drawn, and my picture looks pretty darn good. This is the best circle I think I've drawn every day, or all day, to get it to fit the triangle I already had. So now find sine, cosine, and tangent. So Nick, how can we find sine with our beautiful circle that we've drawn over here?
You take the y over the radius of
Yeah.
3/5.
3/5. Nick, what's the cosine of our triangle?
4/5.
And what's going on with that 4?
It's negative.
It's negative. So because we're on the negative x-axis, that's a negative cosine value. And then tangent is?
3/-4.
Yeah. That's also negative because we're on the negative x-axis. So if you're on the negative x-axis, your x's are negative, meaning the cosine contains an x, the tangent contains an x, so they're negative. Even though the distance of the triangle is still positive, it's still a negative value. Questions? Libby?
So even though that technically is triangle.
The original angle, yes, would be obtuse, but we're going to use that, create a triangle using the other side of the x-axis since that's the side we're on. Other questions? So if you look down below, this is a little bit of review of the unit circle. So kind of flip-flopping back and forth. If you have an angle that you recognize, then that means it's an angle from the unit circle. So pi/3, pi/4, pi/6, 0, pi, 3 pi/2. Those are the ones that are on the unit circle that you would need to draw a triangle for. You can always draw yourself some type of picture though. Sometimes just having a little visual helps. But if we have a 0-degree angle, here we go, that one is not a good circle. And we're at the edge of that circle. Chelsea, what's the ordered pair at the edge of a circle for a 0-degree angle?
1, 0.
So what is the sign, Chelsea?
It's 0.
Yeah. Because it's the unit circle, the sine is just y, the cosine is just x, the tangent is y/x. So if it's an angle you recognize, then those would be the definitions that we've talked about. So sine is y, cosine is x, and then Chelsea, the tangent y/x would be 0, yeah. So the middle one now wants you to think of the angle of pi. So again, if you need to draw yourself a little picture, think of where pi is located. That's now at -1, instead of +1. So Virginia, the sine of pi is? Yeah, sine is just 0. The sine is the y. The radius would be 1. So 0 divided by 1 is 0. Virginia, the cosine would be -1. And then the tangent is 0. Y divided by x. So the last one, we have 3 pi/2. That's down at the bottom of the circle. Michael, what's the ordered pair that's at the bottom of the circle?
0, -1.
So that means cosine, sorry, hold on, start with sine. Sine is,
-1.
cosine is,
0
but tangent,
is non-real
why not?
because you can't divide by 0.
Right, tangent is -1/0. That doesn't work. So tangent is undefined. Can't divide by 0. So those are common angles. there can be any angle, there's common angles. If it is an angle that you don't recognize, draw yourself a triangle. If it's an angle you have from the unit circle, then you just think about those ordered pairs where it is. Either by a 30, 60, 90 triangle, or again, having just a couple of numbers memorized from the unit circle. Questions? So the chart at the top of the next page, just kind of a summary chart, and I said we were going to come to this again today, talking about the signs of trig functions, and this means positive versus negative. So which function is positive, which function is negative, if you're in a specific quadrant of the circle. So we have those 4 quadrants moving counterclockwise. So thinking about the ordered pair in that quadrant, because that ordered pair kind of determines is sine or cosine positive or negative, and the fact that cosine is x, sine is y, or cosine is x over r, sine is y over r. That r part doesn't really matter. It's the x and y that we've got to be thinking about. So Chelsea, if you're in quadrant 1, what happens with the ordered pair x and y? They're both positive. So when you think about the trig functions and just the main 3, so sine, cosine, and tangent, what's going on with sine, cosine, and tangent in the first quadrant? Brandon? They're all positive. So every function is positive in the first quadrant. All of them are. Because if x and y are positive, that means sine has to be positive, cosine has to be positive, tangent is y over x, that's also positive. So all of them are positive in the first quadrant. If we're in the second quadrant, Sabrina, what's going on with x and y in the second quadrant?
The x becomes negative and y stays the same.
So with respect to the 3 sine, cosine, or tangent, which one of them would be positive? So think about x and y, what they represent with sine, cosine, tangent. Brandon?
Would it be cosine? No, sine.
Sine. So sine is y. Here's the y. That means the sine and its buddy, the cosecant, are positive functions. Everything else would be negative. So cosine is negative because it has an x. Tangent is negative because it's y over x. Cosecant would be positive because its buddy is with the sine. So looking in the third quadrant, Virginia, what's going on with x and y in the third quadrant? They're both negative. So Virginia, what does that mean with the positive trig function then? Yeah, tangent and cotangent. Because tangent is negative y over negative x, well, that's positive y over positive x. And then the last one, we would have a negative y since we're on the bottom. The only function we haven't talked about yet is cosine or the secant. So those would be your positive functions. So I'm always trying to get you to remember them in some crazy way. I learned it all students take classes, starting in the first quadrant, moving counterclockwise. All students sine, take, tangent, classes, cosine. Some people have said it's cast. So if you're in the cast of a play, starting in the fourth quadrant, C-A-S-T, just some way to get you to kind of help remember which function is positive because it's in the first quadrant. So that helps when you're looking at your values, trying to locate an angle based off of something being positive or negative in the quadrant that it's located in. So the last problem we're going to do today kind of talks about functions being positive and negative, the location of them. And that is this last example here. So it has the tangent being negative 5/4. So they're now saying the tangent is negative 5/4. And the cosine is greater than 0. So cosine, if it's greater than 0, what's that mean? Cosine is greater than 0. Brandon?
It's positive,
Okay, so cosine is positive.
and it's in quadrant 1 or 4.
Okay, so cosine is positive, so it's either in quadrant 1 or it's in quadrant 4. And that's just because cosine is positive. So looking above, Cosine, all of them are positive in 1, cosine is positive in 4. Brandon, if tangent is negative, what does that mean?
It's in quadrant 4.
Yeah, so negative means tangent is either in quadrant 2 or quadrant 4. And the overlap, as he said, would be in the 4th quadrant. So we're still going to try and draw a triangle, but we need to figure out the location of the triangle. And that would be kind of your thought process. Find out where your triangle should be located. Well, it's going to be located in quadrant 4 because that's where both of them would exist. So tangent is negative in the 4th quadrant, cosine is positive in the 4th quadrant. So the properties kind of overlap there. So I'm going to make ourselves a little triangle. That triangle still has the terminal side of an angle. It still starts on the positive x-axis. But we're going to make it in the 4th quadrant because tangent is negative, cosine is positive. It satisfies both conditions. The next thing, after you determine the location, we have to label this triangle. So if we have the tangent, what two sides of the triangle would be labeled with tangent? Brandon?
Opposite and adjacent.
Opposite and adjacent, or y and x. However you want to think about it, either opposite and adjacent, y and x. So y is 5, adjacent is 4. Brandon, which one of those get the negative signs? Yeah, the 5. Because my y has to be negative. So we have a positive x, negative y in the 4th quadrant. That's why the 5 gets the negative sign. Chelsea, question? Oh, okay, sorry. And then the last thing we have to do is get the hypotenuse, which is the square root of x squared plus y squared. Square root of 41. So make sure when you're sketching your triangle, sketch it in the correct quadrant based off of the information that you have. And you'll be given usually 2 pieces of information. And then the last thing, it just wants us to get the trig functions. So we now have a diagram drawn. We can find sine, we can find cosine, cosecant, secant, and then the cotangent. So sine is y over r. Well, y is negative 5, r is the square root of 41. Y over r. If we rationalize that, that makes negative 5 square root of 41 over 41. That would be the sine, y over r. Cosine is x over r, so x is 4, r is the square root of 41. Or 4 square roots of 41 over 41. The cosecant is the reciprocal. I take the unsimplified version and flip that around. So we had negative 5 over the square root of 41. So now we would have the square root of 41 over 5, and it's negative. And then cosine flipped to become secant, so square root of 41 over 4. The cotangent is the flip of the tangent. So we're still drawing triangles, except now we'll have positive and negative values. The triangle needs to be drawn in the correct location. Questions? So your homework, you'll be creating some wonderful triangles. Make sure you draw it in the corresponding quadrant. Some of the questions might just ask you like the quadrant that it's located in based off of the conditions that you're given.